Hi everyone, Senan this side, and let's do the insertion anywhere in a doubly linked list. So let's say you are given a linked list like this, and for the moment let's assume we only have 4 nodes in this list. So the links would look something like this. Okay, so links look something like this, and this would be pointing to null, this would be pointing to null, and let's say this is the head pointer. Now the job is that you are given a position P, or let's say in this case position number. So this is position 1, this is position 2, this is position 3, this is position 4. So what you have to do is, given this node, this new node, this pink node, what you have to do is insert it in such a way that after insertion this node is at position. Okay, now depending on how you take your position, the implementation would depend slightly. So if you take 0 based indexing, your code would be only slightly different. But anyways, let's take this. So to add this node to position 3, which is right here, what I need to do is to reassign 4 links. How 4? So if I insert this right here, so the next of this should point to this node, previous of this should point to this node, right? Next of this should point to here, previous of 3 should point here. So you see 1, 2, 3 and 4. There are exactly 4 links that we have to take care of. So how do we go about this? So let's think about this. First, what I could do is I can initialize the next and the previous links of this pink node. And how do I do that? Let's say I am at node 2, and using this I can set the previous of this to temp, and the next of this is temp's next. So through that I can assign these 2 links. Now that's one thing. Now what I need to do is to assign the next of this 2 to this as well, and the previous of this node to this as well. Then I can do that. Now there is a small thing that you would have to consider. Let's leave that for the moment. So let's write the code and think about this. So before writing the code, to reach or to insert it at this position 3, so that this becomes the node 3, you need to reach 2. And once you reach 2, using this node 2, I can access this node 3, and I would have the access of this node, and this node itself. So I can perform the relinking of these links. So I need to reach this node 2. So to reach position P, I need to reach position -1th node. And to reach position -1th node, I need to jump position -2 times. So if I have to reach position 2 from the head, I need to jump 1 time. So that is why to reach node P, I need to jump P -2 times from the head. So that is for the traversal. So let's write the code and try to understand how do we insert at position. And how do you insert at position? What you do is you take the head. So whenever you write a linked list class, this head would be a private variable, so you could access it directly without passing it to the function itself. Next is you also have to take a value through which you would initialize the node, and after that you'll take a position as well. Now I am assuming this position that you give is valid. By valid I mean it is in between the range this to position is then equal to length of linked list plus 1. Why plus 1? Because you need to adding at the tail. So what we are trying to do is go to the node before, right, to insert. So let's say we have only 4 nodes, but we have to insert at position 5. To insert at position 5, I need to reach position 4, and to reach position 4, I need to jump 3 times. 1, 2, and so that is why we can have position as 5 as well, which is 1 more than the length of the linked list. So that was explanation for that. Now assume this to be valid. I'll just assume that it is not written there. So the very first thing is, whenever you have to insert a node, the very first thing is that you have to create a node, right? So let's say node star new node, right? And what you do is do the keyword new node, and let's just remove this new node value. One more thing that you have to consider is that if your position is invalid, right, so you are allocating memory for that. So in that case, you need, if position is out of bounds, you need to deallocate the memory for this, or you can just create this new node as and when required. So let's create this new node for the moment, and we'll do the changes necessary if required. So once you create this new node, what you have to do is to reach the node just before that. But even before that, if position is equal to 1, that means this is what insertion at what? Insertion at head. So we'll write the code for inserting at head. If that is the case, let's do this. So what I'll do is I'll say that new nodes next is what would be this head, and then I have to reassign the link from head back to new node. Heads previous is equal to this new node. So I have the initial two links, node new node to head, head to new node, and then I can just reassign the head to this new node, and then what? Then I just return the head, and we're done with inserting at head. Now the next thing, we have to traverse to reach the node that is just before the position, right? So let's do or rather than using a while loop, let's use a for loop. For I equal to 1 to position -2, and what you do is you perform the jump, which you say temp is equal to temps next. But for using temp, I also need to have the node temp itself, right? I'll just take this down. I'll say temp is equal to the head. So now I have temp as head, and I know this head is not non-empty. So what I'll do is I'll say that temp equal to temps next, right? Now temp is equal to temps next, and this would allow us to go to the node which is just before the node to which we have to insert. Now there is one more thing. Let's say if position is out of bounds, let's say you have given a position which is very large, or it's longer than the length of the list. So in that case, what you do is you add another condition and temp. If at any point temp becomes null, you get out of this loop, and what you do is you check if temp equal to null. In that case, what you do is just technically you have to return, but since we've allocated memory, I'll just delete this new node, and then I could just return. Okay, if temp is null, just delete this new node and I return, because you're trying to jump to a node which does not exist, and if that node does not exist, there is nothing to insert a node after that. That's the simple idea. So in this, let's say if I give you position as 6, so you need to jump 4 times. So 1 2 3, and I try to jump 4th, so I am now at a node which is null. So since I'm at a null node, that means I cannot do the insertion after a null node. Because of this, we have to do this if check. So now we are at a node temp. The node that we are is the temp node, and I know there is a next pointer to this, and it might have a next node. So it would have a previous pointer to this. I have this new node. I need to reassign the links. So first, just reassign the links of, or just assign the links of this new node. Let's do that. So what I would do is I'll say this new nodes next is what? New nodes next would be equal to temps next. Fine. Now new nodes previous is what? Temp, right? So given this temp, given this new node, given this next node, what I'm trying to do, assign this, the next node of this equal to this, and the previous of this to temp itself. So that is the thing that we are actually doing. So we've assigned 2 links. Now there are 2 more links remaining. Now the next thing is what I need to do is given this, right? So what if say let me draw this again. Let's say, and let's use the color pink. So what I have done is like this. So the next is pointing to this node, the previous of this is pointing to this node. Now I have this node which is pointing to this node, right? And the previous of this is pointing to this node. Now the access to this node is I am getting through this temp node, right? I don't have this node itself. So temps next, and this previous link only exists when this temp is not null. You get that, right? If temps next is not null, only after that I am actually able to reassign the previous link to this by removing this node and assigning it to this new node. So if this node is null, that means we are adding it to the tail. So what I can do is just add a condition that if temp next is not a null node, temps next is not null, that means it is a valid node, and because it is a valid node, I can reassign the previous to this new node. You can say temps next, and the previous of that, temps next previous link. So this link is now equal to this new node. Let me just write this below this. Temp next previous is actually this null node. So temps next is this node. If it is not null, then there exists a previous. So if that is the case, you assign this to not null but to this new node. So I have removed this link and I have attached this link. So what is left is to change this link to this new node. So in that case, what I can just say is temps next to this new node. Now if you see, the order in which I'm writing the statements actually matter. Let me just, so if I write the statement before this, then we lose the track of the actual temps next node. So first we need to reassign the next node's previous, and then we can assign this temps next node. Now after this, what I could do is just close this function and return head was. So that is the thing, right? It's a function and it's simple as well, but you just need to take into consideration that when is a node null, when it is not null. So through this function, I am always ensuring that temp is not a null node. So I know this node exists. Okay. The next is we need to insert this node. So we have created this node. So this also exists. This also exists. The only thing that we are not sure of is this temps next. So if this exists, then we have to assign the link, the previous of that to this new node. Otherwise, we don't do anything. So yep, that is a thing. And you see, if what we are trying to do is new nodes next is equal to temps next. So if this is null, then there's not an issue, because if this is the last node, I'm just saying that point this to null. So this is fine, which is already null, but we still reassigning for our safety. So that was the code. Now, if you see, we are traversing position -2 times, and this at max would go to how many? This would go to the length of the linked list, because if it goes beyond the length of the linked list, this condition would force it to come out of this for loop. So through this, I can say the time complexity is order n, and after that, every operation is order 1 operation. So through this, I can conclude that time complexity is actually order n, which is the length of the linked list, and space complexity is order 1, because we are just adding a new element. Now the space taken by the linked list is different, space taken by this function is different. So order n and order 1. So that is about inserting at any position. Now let's say if you have, let's say, 0 based indexing. Now inside this function, to change this to a 0 based indexing, what I could do is wherever I have written position, I just replace that with position +1, right? If you just replace this code would work fantastically. So that would mean that this 1 would become 0, and this position, this would be position -1 and not -2. And that would just convert this code to a 0 based indexing function. Also, if you want, you can just add a condition that if position is less than 0 or less than equal to 0, what you do is you just return, because you cannot insert at a negative index according to the way that we have defined the problem. So that is the video. I have discussed the time and space complexity, and yep, that's it. And I'll see you in the next video. Bye.